Okay, great. Here we go. Okay, so we are now live. So hello everybody, welcome one and all. What you see on your screen is the brilliant Jessie Baldwin. She hasn't learned to throw her voice and deepen it. It's me, Sam Westwood, in the background, and also Dr. Stanley as well on my lap. Thank you everybody for joining, and we're really looking forward to today. But before we do get onto the main event, I'll just do a few announcements. We've got loads of upcoming speakers across the Right Sides, and you can find them all on our Twitter page at Right Science Club, or our website, which is www.rightscience.co.uk. Some people might have issues accessing it because there's a kind of a security issue where people get flagged as entering an unsecure site, but you can just bypass that, that's okay. In terms of housekeeping, if you join late, don't worry, you can pause and rewind. This is a live events platform which allows you to do that. We've also got closed captions as well, so auto subtitling if you want to read along as well as listen and watch. Questions can be asked via the Q&A message board, which should be on the right hand side of your screen, and you can just submit your questions and we'll feed those to Jessie at the end of the talk. The talk will be uploaded to our YouTube channel, where you can find loads of other past talks as well. Okay, so I think that's all of the housekeeping done. So now on to introducing our guest today. So we're joined by Dr. Jessie Baldwin. Jessie is a Sir Henry Wellcome postdoctoral fellow at UCL and a visiting researcher at the SGDP Centre at KCL. Before that, she completed a degree in psychology at the University of Warwick before going on to do an MSc and PhD in the SGDP under the supervision of Andrea, Danese and Louise Arseneault. Jessie's research focuses on the role of childhood trauma in mental health, and as part of this she's interested in using quasi-experimental methods, for example genetically informative designs, to strengthen causal inferences about the effects of childhood trauma. And she's also heavily interested in meta research, and is keenly and is sort of advocated via being a co-lead at ReproducibiliTea Journal Club at UCL. And I was also fortunate to co-organise an event with her, gosh, 2 years ago, I think now. So Jessie, I'm going to hand the floor over to you. Thank you again for putting time aside for us today. And yeah, the floor is yours.
Cool, thank you, Sam, and thanks so much for inviting me. I'm a big fan of the Rights Club, so it's a real honour to be here today. So yeah, I'll be presenting on protecting against researcher bias in secondary data analysis. Okay, so as humans, researchers are vulnerable to a range of common subconscious biases that can affect the way that we analyse, interpret and report data. So these biases can include things like apophenia, which is the tendency to see patterns in random noise, confirmation bias, the tendency to selectively focus on information that's consistent with our own beliefs or preferences, and hindsight bias, which is the tendency to view past events as predictable only once they've happened. And these common cognitive biases can contribute to questionable research practices, which I'm sure most people here are familiar with, such as p-hacking, so running multiple analyses in order to obtain a statistically significant result, selective reporting of findings that are statistically significant, novel, surprising, or with a clean narrative, and harking, hypothesizing after the results are known in order to make a finding appear to be more compelling. And in secondary data analysis, the potential for these researcher biases to distort the research outputs is potentially especially acute for a couple of reasons. So firstly, researchers often have access to large, highly dimensional data sets, which offer many different ways to analyse the same research question. And we know that different analytic choices can lead to different results and different conclusions. And secondly, in science, the current incentive structures really reward us for publishing statistically significant, novel and surprising results. And so this combination of opportunity with the data and incentive might lead researchers to run multiple analyses and only report the most kind of publishable findings. And so one way to protect against the effects of these researcher biases is to pre-register study designs and analysis plans, for example, on the OSF, another pre-registration website, or through registered reports. But based on my own experiences and experiences from my colleagues and collaborators, it seems that pre-registration can pose some challenges for secondary data analysis. So in this talk, I'll describe some of these challenges and suggest some potential solutions that we and data managers and the wider research community might considering adopting to either make pre-registration more effective and feasible, or to present an alternative approach to mitigate these potential biases. Okay, so the first challenge for secondary data analysis is having prior knowledge of the data. And this is because researchers often analyse the same data sets multiple times throughout their careers. And this is usually for good reasons. For example, the data sets might have really good measures, or they might have other advantages that are particular strengths for our particular areas of research. But on the downside, having prior knowledge of the data might lead to potential insight into the results and induce bias in that way. And so in order to kind of increase transparency about this, one thing that we can do is report our prior access to the data. And this is actually now required when we pre-register secondary data analysis plans on the OSF according or in line with the template that was developed by Olmo van den Akker. So in particular, we're encouraged so for each author to state whether they've accessed the data set previously, and if so, whether they've accessed key variables and which ones, such as exposure variables or outcome variables, and to also include a citation of the resulting publication to kind of provide additional transparency about what analyses were conducted when using the dataset or the key variables. And this information can be provided through self-certification, which obviously does rely on trust that the researchers are being honest. But other more objective ways to provide this data could be through a letter from an independent gatekeeper, such as a data manager, explaining which of the authors have accessed the dataset previously and when and which variables they might have accessed. Or alternatively, if cohorts set up some kind of electronic data checkout system, which could involve, for example, just automatically recording which researchers might say download the data or be sent the data, the date they've accessed it, and so on. That would be really helpful, because then researchers could just search the name of their co-authors and have the kind of history for each author of whether they've accessed the data set previously and what that data access involved. And it's important to highlight that just reporting our prior access to the data doesn't prevent biases linked to prior knowledge of the data, but it does make these biases transparent. But for a more rigorous solution that can really help to mitigate against these biases, researchers can consider using a multiverse analysis. So a multiverse analysis is an approach which involves identifying every potential analytic choice that can be made or that can be used to analyse a particular research question. So every possible different type of analysis that could be done. So this includes things like different ways to operationalise a variable, different ways to code a variable, different statistical models to use, and different patterns of covariates. And these all need to be justifiable. So only things that could reasonably be done for kind of good reasons to test the relevant question. So once all of these different analytic choices have been identified, and these are often termed specifications, researchers run all of the different analyses, which often include thousands, and then they can report the results from all possible specifications. And so this graph shows an example of a multiverse approach by Amy Orban, looking at the relationship between digital technology use and well-being in adolescents. And so down here we see the different analytic choices. So, for example, different ways to operationalize technology use, different measures to indicate well-being, different informants, and different statistical controls. And each dot represents the particular specification or combination of all of these things that were included. And then up here we can see the effect sizes associated with the different specifications. So you can see that the effect sizes really range quite considerably from a moderate negative association to a kind of small positive association, with the average effects shown here. And so this approach is really effective in preventing things like selective reporting, because it shows the results from all possible analytic approaches. And it's very transparent in this way, which means that it's really effective in situations where researchers have already accessed the data, because although they might have maybe some insight into the potential results, it's extremely unlikely that they would have conducted thousands, here 20,000 different analyses to test this question before pre-registering. So it can really help to prevent the biases that might lead to selective reporting or p-hacking and things like that. So while this approach is really rigorous, that potentially has a bit of a downside in that it could be quite computationally demanding to run and potentially quite challenging to come up with all of these different specifications. But there are new packages that are being developed or that have already been developed to kind of standardize this process and make it more efficient. So I think that's really optimistic for future multiverse analyses. Okay, so the second challenge that pre-registration can present for secondary data analysis is that the research may not be hypothesis driven. So pre-registration and registered reports are really tailored towards confirmatory hypothesis driven research. But much research involving secondary data analysis is descriptive, exploratory, or more focused on estimation. So, for example, testing the magnitude and robustness of an effect size. So this might lead some researchers to think that maybe pre-registration isn't relevant for them if they don't have a strong and clear hypothesis. But one solution to this is to pre-register research questions, analysis plans, and conditions for interpretation. And this is because research based on secondary data analysis doesn't need to have a hypothesis to benefit from pre-registration. Pre-registering research questions that are very clear and specific and analysis plans can help to limit analytic flexibility and prevent selective reporting and p-hacking. And pre-registering specific conditions for interpreting the results can limit post hoc interpretations. So by interpreting the results in a slightly biased way only once you've observed them. And there has been, or there is, detailed guidance on the OSF template for pre-registering secondary data analysis about how to pre-register research questions and analysis plans in kind of sufficient detail. But in terms of pre-registering conditions for interpretation, here's a kind of a small example, which I won't go into too much detail about, but the aim is to really pre-specify as much as possible all potential different results that you might obtain. So here, for example, with this research question, we might obtain 3 kind of broad patterns of results. And for each result, to state what interpretation you would make from that. The more detailed, the better, really, because that really limits the space for additional kind of post hoc interpretation. So you might also want to consider things like effect size thresholds for interpretation. So what you consider to be a small, medium or large effect and how that would affect your interpretation and meaning that you draw from the results. And things like the smallest effect size of interest in the context of equivalence testing. And it's worth noting that pre-specifying conditions for interpreting results is recommended, if not mandatory now, in registered reports. So it could be worth having a look at example registered reports and just seeing how exactly they come up with these kind of different results and then how they would interpret each one. And really, the more detailed and specific, the better. Okay, so for researchers that are interested in integrating pre-registration into a kind of exploratory approach, they might consider using a holdout sample. And so this involves taking a data set which needs to be sufficiently large and randomly splitting it into a training data set and a holdout data set. So on the training data set, you can conduct exploratory analysis, so kind of free from hypotheses and testing whatever you want really to make new discoveries in a really flexible way. After this exploratory analysis has been conducted, researchers can then pre-register the study based on maybe testing some of the research questions or hypotheses that might have been generated from the exploratory process, and then conducting the pre-registered confirmatory analysis in the holdout sample. So this approach kind of enables a really flexible discovery process before testing more confirmatory analyses in a non-biased way. And it's particularly could be useful for situations when access to independent data sets is limited, although it needs to be, or the original data set does need to be kind of large enough to allow sufficient power in the holdout sample, given that this is a reduced sample size from the original data set. Okay, so the third challenge of pre-registration is to ensure that the pre-registered analyses are appropriate for the data. So with pre-registration for all different types of data, including primary data, there's always a risk that the analyses will not be appropriate for the data, perhaps if the data violate an assumption of the analysis. But with secondary data, the extent to which the data can shape the analyses can be quite considerable. So as some examples, with longitudinal cohort studies, there's often attrition and missing data. But the kind of type of analysis that you might do to account for the missingness really depends on the characteristics of the missing data, such as whether it's missing at random or not. Additionally, much kind of secondary data that we might use, such as electronic health records, was never actually collected with the purpose of research. So there could be many challenges in analysing the data that are really impossible to predict in advance. And also, more generally, characteristics of the data often shape the analyses that we do. For example, we often have to check things like collinearity before kind of choosing predictors to go in a multivariate regression model, or understanding the kind of amount of missing data if we're deriving a kind of composite score. So researchers might be kind of concerned about pre-registering specific analysis plan without having some kind of understanding of the data characteristics. So one solution to this is to trial the analyses on a blinded data set before pre-registering. And what I mean by a blinded data set is one in which the values are obscured, or the data labels are obscured. So researchers don't gain any insight into the actual results, but they do understand some of the characteristics of the data. So one form of data blinding is known as data scrambling. And this basically involves taking a data set and randomly scrambling or shuffling the values within rows or within cells. So if we take this kind of simple data set as an example, if we scrambled it by columns, the scrambled data set could look a bit like this. So focusing on the first column, we see that we've got values of 5, 3 and missing. And then in the scrambled data set, the values remain as 3, missing and 5. So the values are the same, but they're just in different cells. And importantly, this means that the data distribution is the same in the blinded data set. So the means and the variances will all be the same. The amount of missingness is also the same in the blinded data set. So we can assess kind of the amounts of missing data that are present. But importantly, any associations between variables will be different in the blinded data set, so we wouldn't gain any insight into the overall results. And so this is a kind of approach that could be implemented at the cohort level. So for example, if a researcher is interested in pre-registering an analysis on that data set, the data manager could provide a blinded data set for the researcher, so they can assess some of these characteristics of the data, potentially refine some of their analyses if they find that some of the assumptions are violated. And then once they've refined the analyses, they then can go ahead and pre-register the study analysis plan with more confidence that the kind of analytic assumptions won't be violated when they come to do the analyses. So one really minor, or maybe not so minor, but one limitation with this approach is that although we can assess the data distribution and the missingness, because we can't see any associations between variables, we wouldn't be able to assess some things, for example, like collinearity between variables or even predictors of missing data. But the following solution can address those problems. And this is basically to do something really similar, but to trial analyses on a data set missing the outcome variable. So, for example, a data manager could send the researcher a data set with information on the exposure variables, the covariates, but no data on the outcome. And this could mean that researchers could assess multivariable distributional characteristics and assess things like collinearity between variables and predictors of missing data. But crucially, they wouldn't be able to look at any relationships between exposures or covariates with the outcome, which is usually the kind of main point of interest or analysis done in the actual research that they want to conduct. And if researchers are kind of concerned about the fact that they wouldn't have any data on the outcome, so they wouldn't know the amount of missing data in it, for example, or the distribution, this approach could actually be kind of mixed with the data scrambling approach. So researchers could receive a scrambled outcome variable. So they're able to assess the distributional characteristics of the outcome. They still wouldn't be able to look at any relationships with the exposures. Okay, so the fourth challenge relates to a lack of flexibility in data analysis due to pre-registration. So researchers have raised, or some researchers have raised concerns that pre-registration can limit necessary flexibility in data analysis, for example, to make new discoveries in exploratory research, or to implement a new kind of advantageous method that's recently developed, or to kind of follow up on an interesting finding with post-hoc analyses. And as I'll kind of come to discuss, this concern is perhaps overstated, because actually pre-registration doesn't prevent researchers from doing this, but it just encourages them to make it more transparent what's post-hoc and what was pre-registered. But another understandable concern that researchers might have is that pre-registered studies have been associated with a higher report or greater reporting of null findings. So yeah, pre-registered studies, when empirical analyses have checked this, they found that pre-registered studies are more likely to report null results. And this is likely because pre-registration reduces analytic flexibility and prevents these questionable research practices like p-hacking. And although reporting null results that are true is a really positive outcome for research integrity, researchers might be concerned that this might kind of damage or harm their careers in some way, because we also know that, unfortunately, in the current climate, and especially in the past, null findings are harder to get published, and they're also less likely to be cited. So there could be a concern that by kind of committing to pre-registering, you're more likely to have to report null results, and it could be more difficult to get your paper published. So to address this, I think we can take steps to ensure that the value of a paper doesn't depend on having statistically significant results. And there are a number of ways that we can do this. So firstly, by adopting high quality methods, we can increase the likelihood that our paper will make a valuable contribution regardless of the findings. So kind of taking the time to think carefully and thoughtfully about our study plans when we're designing it, and taking steps to make sure we have high power, we're using valid and reliable measures, implementing robustness checks to kind of rule out alternative explanations, and using replication samples to kind of test the generalizability of our findings. We can also implement alternatives to null hypothesis significance testing, such as Bayesian methods and equivalence tests, which allow better interpretation of null findings, which is in contrast to traditional null hypothesis significance testing. And somewhat related to this, we can also place more emphasis on things like confidence intervals rather than p-values. So focusing on kind of the magnitude and range of effects rather than simply whether it's statistically significant or not. And finally, arguably the most effective way to prevent ourselves from publication bias is to conduct a registered report, because if the study is deemed to be of a high kind of importance in terms of the topic, and the methods are considered to be really strong, then the journal will commit to publishing the study regardless of the results, if it's kind of accepted after the stage 1 peer review based on the quality of the protocol and the topic importance. And in relation to the concern that pre-registration can limit flexibility in conducting unplanned analyses, I think it's quite or more well known now, but these can be included, but they have to be transparently reported. So, for example, researchers, if they're using a new method, for example, they can highlight either in an amendment to the pre-registration or in the manuscript, potentially in the supplementary material, if there's a tight word count and they're linking to this from the main article so it's clear. They can report the changes to the study, the reason why the change was made, for example, if a new method offered particular advantages, or something went wrong with the previous analysis, if the data maybe violated some of the assumptions made. And ideally, if possible, report results from the original method to show that the choice in deviating wasn't because of the results, it was because of the other kind of methodological reason. And this is now the kind of option to include an amendment to the pre-registration is now available on the OSF pre-registration site, so that's really handy. And it can also be reported in the manuscript. Okay, so moving on to the summary and discussion. Pre-registration can pose certain challenges for secondary data analysis. And these include having prior knowledge of the data set, having non-hypothesis driven research, ensuring that the analyses are appropriate for the observed data, and issues related to reduced analytic flexibility. But the approaches that I've described here aim to address these challenges. And in addition to researchers kind of taking initiative to adopt these methods, data managers also have a role to play in adopting these approaches. For example, in reporting data access from authors, providing blinded data sets or kind of data sets missing the outcome to researchers so they can trial and refine their analyses prior to pre-registering, and providing holdout data, and just encouraging pre-registration more generally. And as well as researchers and data managers, funders and journals can also really help to incentivize these practices. So some potential ideas could be that funders might provide grants to establish best practice at the cohort level, such as recording how best to record data access and how best to provide blinded data sets. And for example, journals might provide a designated space in articles to report deviations from the pre-registration. So this could be kind of exempt from the word count to encourage researchers to be really transparent with reporting this, and also just to normalise the fact that deviations from the pre-registration are really normal and actually a natural part of the scientific process. And overall, initiatives that increase the ease of adoption of these methods will lead to wider uptake. And I think this point links to a kind of broader, really important point that the responsibility for adopting open science methods more generally shouldn't only be like a burden on researchers, but actually wider stakeholders like funders, journals, institutions really need to provide incentives and support that allow researchers to do this, and kind of together help us to conduct more reproducible research that can ultimately benefit science and society as a whole. So thank you to my collaborators for their help with and insights in this commentary piece, and it's published in the European Journal of Epidemiology if you're interested to read more, and I'm really happy to take questions and discussion points.
Brilliant, thank you so much, Jessie. That was wonderful talk, really clear and very informative. For the audience, if you want to ask questions, you can do so via the Q&A board, which should be on the right of your screen. So you just submit one and then I can feed them to Jessie. Whilst people are thinking, and there is a sort of a 10 to 20 second delay on the feed, so we may be a bit of a delay for people submitting their questions. So whilst we wait, I've got a couple of questions. So I did sort of prime you beforehand with a couple of questions, but I'm going to throw you slightly and ask a question that only occurred to me during your talk, and that is just going back to the slide on the training data sets and the sort of holdout data sets. So you don't need to go back. It was more of a different question, actually, a related one to that, which is using synthetic data sets. And is that in your paper? Is that mentioned anywhere? And if not, why not? Or just, yeah, what are your thoughts on synthetic data sets?
Yeah, so I think that's such a cool idea. It is mentioned in the paper, but not so much in the context of pre-registration, but we actually have a table discussing challenges of other open science methods for secondary data analysis. And one of those challenges is sharing data, because many of these cohort studies and kind of electronic health records and things, we can't share them because of ethical issues and a lack of consent from the participants. But synthetic data sets, I think, are a really great solution to that, because it basically involves simulating a data set with the same properties and characteristics as the original data set. So it means that you can post a synthetic data set, and then other researchers can run your analysis code and kind of check that your findings are broadly similar. And they wouldn't be exactly the same, because obviously the data is simulated, but they should be very kind of broadly similar if you've simulated it correctly. And I know that there are like R packages that allow you to do that reasonably quickly, I think. But I think in terms of the issues that I was talking about relating to kind of providing blinded data sets and things so that researchers can trial their analyses before pre-registering, I don't think that a synthetic data set would be that suitable, because it might be too similar to the original data set. So you'd probably get some insight into the results if you tested your analyses on a data set that had really similar properties to the actual one you wanted to use.
Brilliant. Yeah, just to quickly jump on the back of that as well. So Dan Quintana did do a talk for the Riots Club about synthetic data sets, and he talks through the kind of the limitations and the applications of synthetic data sets, not just as a training data set, but as you say, Jessie, as well, you know, it could be a way to test the computational sort of reproducibility of your analysis pipeline. So I just flagged that up as well. We do have a question from the audience. So amazing talk, Jessie. I have a question. Is there a guide somewhere on how to conduct multiverse analysis?
Oh, yes, there must be. I'm not 100% sure of the exact like citation or reference, but I'm pretty sure I've came across them when I was writing this. Maybe if you look in the references of the article, or for sure if you read like Amy Orban's study on the specification curve analysis, there will be, well, that in itself is really informative, and also I think it should link to some of the key references. And I know that some R packages have been developed to run the multiverse analysis. So I think they come with a kind of step-by-step guide too, like in terms of the actual statistics. And I think I've cited those in the paper. So those should be handy.
Yeah, I'm pretty sure there must be. I'm just scrambling myself. So I am aware that for Glasgow reproducibility, Amy Orban did give a hitchhiker's guide to the multiverse, and sorry to sort of be so particular, but the Riots Club did host Julia Rohrer. So she did a wonderful sort of overview of the different. It's not as simple as people tend to make out what Multiverse is. There's lots of different ways of doing it, and for different research questions. So she gives a different approach of like cross-examining the different approaches, which is quite good. I haven't seen Amy's talk, but I'm sure that's very useful too.
Yeah.
So I'll put a link to that talk in the Q&A. So yeah, keep the questions coming. So let me have a look on time. So let me just bring up another thing as well, which is so pre-registration is good, providing that people stick to it, and if they do deviate from it, they disclose any of those deviations. But as we all know, not many people do. Well, I won't say not many, but there are issues around reporting when they have deviated, and sort of lack of awareness around exactly how you do that. So in your paper, do you sort of pick up on this thing, or do you have any kind of thoughts about issues with undisclosed deviations from analysis plans and how to deal with them?
Yeah, I mean, yeah, we actually have a kind of a table, I think, that does outline some of the limitations of pre-registration, and one of them is exactly that, that although theoretically you should report your unplanned analyses, when these studies have actually, like meta-science studies, have tested the correspondence between the pre-registered protocol with the final published article, they found that actually every study deviated, and a really tiny proportion of studies actually reported that transparently, their deviations. So I guess a recommendation could be that as reviewers, we do need to check the pre-registrations too, as well as the article. And I think is that maybe work that you might have been involved with, Sam, with researchers at Bristol that are implementing a kind of a trial that aims to have specific reviewers that look at the correspondence between the pre-registration and the actual submitted article.
Yeah, that's right. So Robbie Thibault is the sort of lead, I guess, on that project, which is trying to. So there's been lots of studies to sort of look at the discrepancies, undisclosed discrepancies between the pre-registered protocol, and this is usually in terms of the study design rather than the analysis plan, and the final publication. And main issues are sort of outcome switching, so making secondary outcomes primary outcomes and primary outcomes second, that kind of thing. But yeah, the outcome of that is to sort of help reviewers identify those, which is not an easy task. It's quite labor intensive exercise, and I think they're either writing up or they're still, I don't know where it currently is. I know Robbie's moved to Stanford, isn't it? So that, I don't know where that is now in terms of the progress, but yeah.
I guess just following on that, that's another way that journals could actually support this more, by kind of employing reviewers to check just the discrepancies between the articles, and maybe paying the reviewers or having their own in-house reviewers that check that. Because as you say, Sam, it's a lot to ask reviewers who are already judging other aspects of the manuscript to then go and really closely check the correspondence between the pre-registration and the article.
Absolutely. And so my partner, she works for Great Ormond Street Hospital and as sort of a research administrator, and they have a really good administrative team that doesn't necessarily check the discrepancies, but they do something slightly different, which is quite useful, which is they make sure that the registered protocol is up to date, which is something else that's often missed. So we don't know whether the trial was terminated, suspended, whether it's ongoing, whether it's finished, if it's finished, where are the results. So the kind of gaps in people's knowledge about the status of a trial also includes, is also relevant to this idea of adequately reporting the trial results as well. So that's another thing that I think needs more support and more awareness around organisations such as GOSH that do help try to make things more up to date, and the scientific record is up to date. So I have the couple of questions, and then if there's no more, we can close it. So there's just a couple of questions about issues with that we talked about before starting the call, which is the issues with data reuse. So there's this sort of bandied around phrase of sort of the tragedy of the commons, where if you keep testing, if authors are using this community database, there's a risk that you could test multiple hypotheses and inflate the risk of false positive findings. So it's going back to this idea of p-hacking so what are your thoughts on that? And again, I believe it's addressed in your paper. So what do you say on that issue?
Yeah, I think that's super interesting, and it's something that I only learnt about after having worked on like cohorts for about 5 years, that this is actually a problem. But I think there's a great article, I think it's in eLife, that I cited in the paper that explains this in a lot of detail. And basically it says that this is an issue if different researchers are testing very similar hypotheses again and again in the same data set, because the different tests will belong to the same statistical family, and basically the more tests, or then this kind of violates the like the alpha, or it increases or decreases, but basically it means that we need to correct for multiple testing if we're conducting multiple tests on the same data set at different times, but these tests are all part of the same statistical family. So I guess one piece of advice is to really check carefully the literature, and make sure that you're not testing something that's already been tested in maybe a slightly different way on the same cohort. And if you are, think more carefully about multiple testing, and also to try to replicate findings in different data sets. Because if you test something in a different data set, then obviously that doesn't have this problem. So yeah, we briefly covered that in the paper.
Brilliant. I'm going to ask a slightly unfair question because I've just thought of it, and it's something that, given that you've worked quite extensively with kind of secondary existing data sets, which is dealing with I guess owners, if you like, of data sets. So not all data sets are, say, the UK Biobank, where there's a kind of a formal structure and agreement and arrangement that you have. Sometimes you often are requesting data from authors, and that can introduce all sorts of issues around how the data is handled and how much control the authors have on that data. Just as a very quick example, I recall a colleague telling me a story of a supervisor they had who they had fMRI data, and the colleague of mine wanted to reanalyze the data using this new analysis pipeline. And the supervisor said, well, what if you find a different result? And my colleague said, well, that's kind of the point. We want to see whether the results were dependent on the analysis pipeline, which they shouldn't be if they are robust. So these kinds of issues about, you know, people's brand and challenges to their continuity in their work. In your experience, or whether you touch on it in the paper, are there any advice, tips, things you can signpost to help people navigate that kind of difficult topic area?
Oh, that's interesting. I mean, I guess for cohorts themselves, like, I think the more transparent the information is available about how to access the data set and what variables are there, I think that's really good for just general kind of open science, because there are some data sets that it's just impossible to find out anything about it and how we can go about accessing it and things. I think in my experience, the data sets that I've worked on, it's been data access is really dependent on kind of having a good quality idea that's not been done before on the data. And normally it's not just controlled by one person, it's controlled by like a group of co-investigators. So I think that there would be no dodgy dealings going on because there's a number of people that are responsible. And yeah, but I think just in general, going back to what I just said, like, I think it's nice when cohorts are transparent about what data is available and how researchers can access it, because it's a shame to have great data sets if people can't use them.
Yeah, I totally agree. And I guess it sort of re-emphasises this sort of idea of adversarial collaboration, where if there are misgivings about how the data is being reused, then just make it transparent and part of the kind of peer-to-peer review process of that they can sort of say, well, we didn't sign off on this, and these are our concerns. We do have a question come through, actually. It's a bit of a long one, but the person apologises, and so I'll try and make it clear to you and read it aloud. So thank you, Jessie. This was great. Hope in the near future we will be implementing this widely. I have a very specific questions. I am working on a project in which we find a very different effect among boys and girls, different direction of effect, and a null effect in the overall sample. We did not pre-register testing sex differences. As this changes the main message of the paper, would you advise to report the main null results in the abstract as well as the sex differences? And then actually my question is, would you report post hoc analyses in the abstract, mentioning they are post hoc?
Yeah, interesting question. Well, I think if you think the sex differences are really important and it was kind of a discovery that you've kind of stumbled upon whilst analysing the data, then absolutely include it, but just label it as a kind of post hoc analysis. And I think that's fine to report in the abstract too, as long as you probably also say in the abstract that it's post hoc. Yeah, if you found something that you think is important, then absolutely include it, but just need to be transparent about the part that was pre-registered and the part that wasn't.
Yeah, it's a tricky one, isn't it? Because obviously if you say it's post-hoc, it's less compelling, but it's also transparent. This actually raises a different point, which, let me just check time. I don't know whether there's any more questions coming in, but what I wanted to say as well, which is this idea of sort of iterative pre-registration. For those who don't know, that I mean, and a point that you make in your talk about, your data drives some of your analytical decisions, and you can almost create points in the whole analysis pipeline where you decide what to do next based on the outcome of your data, and you can pre-register what it is you do next. So for example, you might say, like a crude example would be, we're going to run assumption tests, and then we'll pre-register whether, based on the assumption tests, whether we do a parametric versus non-parametric test. So yeah, I guess that's more of a comment than a question, but yeah, what are your thoughts on that?
I think that relates also to the idea of a decision, like pre-registering a decision tree, which is the same, like we'll test these assumptions. If it shows this, we'll do this analysis. If it shows that, we'll do that analysis. And I do include that in the paper, but I have not seen any examples of using a decision tree pre-registration. It's talked about a lot, but I don't know anyone that actually has used it in practice. So although I included it, for example, I've not talked about it now because I'm just not sure how relevant or how attractive it is for people to do, because I think you could go off on just a massive garden path and all of the different choices, and you could include hundreds in the end. So I think probably it's a bit too exhaustive for most people.
Yeah, it sounds good in theory, but I don't see it happening. It's just too labour intensive. I mean, the only kind of example, I guess, is maybe longitudinal studies where they do different waves of data collection and they pre-register it each. But that's very different to, when you have the data and you have no more plans to collect more data and you're trying to plan out how you're going to analyze an existing data set. But yeah. Okay, very interesting. It's good because I had the same reservations, so that's nice. It's validated. Okay, so I think that I'll close the Q&A. So thank you everybody for your questions, and thank you especially Jessie, to you for donating your time to today. Again, I'll put the recording of the talk on YouTube as soon as possible. Jessie, you can stay on the line. I'll close the call and then we'll just quickly have a debrief chat. Okay, so thank you again and bye everyone.
Stop sharing.